In this video, I want to do a couple more examples of polynomial long division. In the last video, I talked a lot about the details of why it all makes sense, and I took forever to do it. I just want to speed it up, show you in a bit faster how to do it. So let's say we wanted to take the polynomial that you can see from the packet, 8x to the fourth plus 6x squared minus 3x plus 1, and we wanted to divide it by the second polynomial, 2x squared minus x plus 2. It says divide it, and lastly it says, is p divisible by q? So that's a question we can answer after we're done once we find the remainder. So we'll know at the end. And notice that I have the setup already there in the packet for you. I noticed one thing that I chose to do was to insert a 0x cubed for when we're missing a particular term within a polynomial. Like with the degree 4 polynomial p, it didn't have an x to the cube term in it. But another way I could write that is, well, it does not have it. 0 times anything is 0. So this is obviously equivalent to the original polynomial up there. And the 0 is nice. As you'll see when we do the division y, it's helpful to do this. Technically, you can skip it, but it just makes it nicer. So let's go ahead and do it. So step 1 is to match. And basically just remember match, multiply, subtract, MMS all the way through. So I think about, again, you could do this divided by this would give me 4x squared would be the match. Now I multiply 4x squared into the entire divisor. So I need to multiply into all three of those terms. That would give me 8x to the fourth. Sorry, let me make it a little bigger so I can write better on my tablet. Then 4x squared into minus x would be minus 4x cubed. And then 4x into 2 would be plus 8x squared. And notice that putting that 0 there makes sure that all of those terms are all nice and lined up well, and there's no missing terms or misalignment of the degrees of each of the terms. And so then step 3 is to subtract. So as I said in the last video, we were going to change all the signs and add. And that would leave me with elimination as it should. 0 plus 4 is 4x cubed, and 6 minus 8 is negative 2x squared. Then we're going to drop down the next term and repeat. So we're going to match 2x squared into 4x cubed. That would be matched by 2x. And you do want to write plus when it's a positive term, because as you know, when we're writing polynomials, you have to put the sign positive or negative in between them because they're not multiplied. If we didn't put a sign, it would mean multiply, which would not be what we mean. So we're going to put positive 2x as the match. 2x into 2x squared would be 4x cubed. 2x into negative x would be negative 2x squared. 2x into 2 would be plus 4x. Then again, we got to change the signs and add. So I'm going to change all the signs in my bottom polynomial. Those would eliminate. In this case, actually, even the x squareds would eliminate. It wouldn't necessarily always happen like that. Then I'd be left with negative 7x and plus 1 from the last term. And I know when I'm done when, like if I think about the next match, and if I want to know if I could keep going, well, I can't take 2x squared and multiply into it to get to 7x because x squared can't multiply to make a smaller degree. So again, the rule here is that once we run into a degree which is smaller than the divisor, we stop. And this is the remainder. And this is another thing about polynomials, which is different than regular numbers, is polynomials, sometimes their remainders actually involve x or x squared. They can have, it's not just necessarily a number when it comes to polynomials. And again, we call this the quotient, we call this the remainder, and this, and that would be that. And so we would say that no, those polynomials are not divisible, because again, the remainder is anything other than 0, they're not divisible. Let's do one more example on the next page. It says, let a of x be that big thing, let b of x be that other big thing, compute a divided by b, use result to fully factor ax and find its zeros. So this last part, if you're like, what does that mean? How do I do that? But the whole point is sometimes, depending on your remainder, you can actually use that information to do something, and that's what I wanted to show you. So let's start off with the division itself, obviously. And your homework from the first couple chapters of polynomials is going to be identifying stuff like intercepts, figuring out properties of the graph, doing division, and starting off with basic skills. But here, I'm going to go ahead and write out x to the fourth plus 3x cubed minus 16x squared minus 27x plus 63. And then on the left-hand side, I'm going to put what I'm dividing by. Also, another thing that I don't know if you were wondering is that with polynomials, you can only divide by a polynomial with equal or lesser degree. Just like with numbers, you can't divide by a larger number and actually get anywhere with the division algorithm. You technically can divide it. Like say I was going to divide 42 by 69 or something. Like this algorithm just does not work. Well, technically you can go into the decimal side, but as I said before, 69 does not go into 42 at all, whole-wise. So already we're kind of stuck on the whole number level. Same thing applies for polynomials. But this one started with 4 and 2, that should always be fine. And another rule for you is that when you're dividing a polynomial with one degree by another, the degree of the quotient should always be equal to the difference between them. So I should always get an x squared polynomial out of this. And of course, if I match x squared with x to the fourth, I would have x squared. Then I got to multiply it all in. That would give me x to the fourth plus 3x cubed minus 7x squared. Change all the signs, bam, 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 and add. In this case, eliminate, and negative 9x squared. Here I'm actually going to drop 2 terms because, as you can see from what I'm going to do next, I'm going to match up x squared with negative 9x squared. And to do that, because this one got skipped due to the elimination, to do that I'm going to need, let's just go ahead and do it. Negative 9 would match up x squared with negative 9x squared. And when I'm multiplying the next thing into there, it's going to multiply into each term. Another thing you could do is you could put a plus 0x here because that one was missed or skipped. But that's something that you don't necessarily have to do. But if you like the column by column organization, you can. But notice I just skipped both of them because they both canceled. But that's why we're actually missing an answer in our quotient, or not missing an answer, we're missing one of the degree terms because it skipped over one. Because they just both happen to cancel out. Anyways, multiplying negative 9 through to the whole polynomial would give me negative 9x squared minus 27x plus 63. And coincidentally, it is exactly the same as what's above. If I change the signs and add, of course that's going to cancel, cancel, cancel. What I'm going to be left with is a remainder of 0. And so I wanted to do an example of, what happens if they are divisible when I get a remainder of 0? And again, the implication here is that when it is 0, that means that those two polynomials, this went into this perfectly, or that those two original, the divisor and the answer will factor and multiply back to make exactly the ending polynomial. And that's kind of what I mean with the second part of this question. It says use result to fully factor a, but basically a was this original polynomial. I now know that these two polynomials have to multiply together exactly to make it because of the remainder of 0. And this is a fact that's often not really understood about division, which is kind of important. But basically, if I take x squared minus 9 and I multiply by x squared plus 3x minus 7, let me fix that square because it's kind of ugly. That must be equal to the original polynomial itself, a of x, which was x to the fourth plus 3x cubed minus 16x squared minus 27x plus 63. And if you're wondering, well, how do I know that that actually does? Well, first of all, assuming I did the division correctly, I just know it has to because it is a 0 remainder, but we could even check it out. Let's make sure, does this actually multiply through to make the original polynomial? Let's just verify. And so to do that, well, we'd have to fully FOIL this out, which would be a total of 6 terms because it's a two-term binomial going into a trinomial. But that would make, in order, x to the fourth plus 3x cubed minus 7x squared minus 9x squared minus 27x plus 63. And if we combined like terms there, that would be negative 16x squared. And notice that that is exactly the original polynomial, right? Yeah, cool. And that's my point entirely, is that those have to multiply back together. It looks like I wrote that they're equal. Sorry, that's supposed to be that they multiply, but that's a little misleading. I'll just do that instead. So my point with here is, well, knowing how to do division is important, but also when we can determine if polynomials are divisible by each other. And in the case that they are divisible, it tells us a way of factoring it. And this is kind of one of the things we're going to be elaborating upon in the upcoming sections, is how do we factor harder and harder polynomials? Because we're going to talk about how the intercepts relate to factoring and how all of that plays back into finding properties of the polynomial. Because the intercepts are a very important part of a polynomial. That's the most important skill when we're talking about solving harder and harder equations. So that all being said, we've figured out a way to factor this. And if you think about going back to algebra, you often learn how to factor polynomials, but we don't really cover how do we factor really, really hard polynomials. What processes do we have for that? And division is an important skill. Now you might be wondering, how did we know to divide by this in the first place? Well, that's something that we're going to discuss and go way into detail about as we keep going through this chapter.